Hello, everyone. Thank you, FMX. Thank you, SideFX. Thank you, VFX. No, not this last one. The last one. Not really. So, hi guys, I'm Hristo. I'm going to be talking to you about Cairos.ai. This is our platform where you can make 3D humanoid animation just by talking to an AI agent. So, kind of riding with the wave, being hip. That's me. My background is in computer science first, then I am a visual effects person since 2009, and I've been doing a lot of simulation work and generative stuff, and naturally I went from 3ds Max into Houdini, I think 2019, somewhere there. And these days, since the VFX work has been a little bit slow, we looked at a bunch of other things that we could do, and this is one of these things. So this is the site for the service. You can check it out. We do not have a mobile version quite yet, but you open up the site at least. And I'm going to actually open it up on the side just to have some fun as I speak. So that's the landing page, and I'm going to log in. And the web app is going to show up. It's kind of this kind of a console interface, so I'm gonna say, have some fun, say hi to people at the FMX. Okay, and it's gonna take 20-30 seconds. Meanwhile, we can do other stuff. So basically, how does it work? Because the fun stuff is talking about the how. So this synthesizes choreographies. The idea is that all useful, cool motions, interesting things that you might want to have in your VFX or with machine learning or previous, whatever projects, are some choreographies. And these choreographies are created from simple motions that can be sequenced up and that are interpreted in a bunch of ways to create novel choreographies from a limited number of input motions. So a practical way to do this is to talk to an agent who is searching for in a vector database of descriptions. This simply means that you'll find out later when we get there. And then we have a sequencer, the Houdini stuff, which is combining these motions into a choreography, which is kind of seamless. And we keep updating this motion database just so we get more and more stuff to choose for the AI agent to choose from. So what are the bets that we made? Meanwhile, do we have something here? Bah. It crashed. Of course, it's going to crash just when you need it. That's natural. So this means that we make some strategic bets. And there is some competitors who are doing stuff like letting you, like betting on motion capture from video, web cameras and stuff, like to solve the data problem by offloading it to the users. But we feel like we don't want to do that. We want to have very high quality motion and very high quality performance, because obviously not every animator is a martial artist or a dancer or an actor or an athlete. So getting the right performer to do the right thing gives you high quality of the motion. And because all of this motion capture, we can have living and organic and natural motion. This also means that this approach means that we don't need to spend a lot of resources training AI models, just because we only use the language model to search in this database, and yes, no model training. And kind of the opposite thing that you could do is that you could try to infer the motion directly, which is, from what I've seen so far, is lower quality, and it's very expensive with training models. So this also means that our inference is also very cheap. All we do is that we ask the language model to go and fetch something from a database, and then it's and this takes this is quite short. There's a couple of things that you see afterwards which are stacked upon the language model, but there are not too many. Okay, so it told me I'm performing the jump with a spin. I said this is cool. Can you warm up a bit before the jump? So it's cool that you actually can converse with it. We're going to talk about this a little bit later. This is not just asking it to search. So yeah, these are the, of course, the Houdini in the backend means that all of the stuff that Houdini already can do and that we can do with it are some things which are low-hanging fruit. So this saves us a lot of time in developing a system like this. The cons are that, for example, the interaction with the environment with this method is going to be challenging. So every time that you need to interact with the environment, we will need to do some procedural system that does some IK or FK changes to the animation. So, you can reach out for like a cup of glass, which is at a different height or anything like this. It's not impossible, it's extra work. Scope of the motion of what you can get is limited to what is there in the database. So if we just have, Roomba in the database, you're not going to be able to get salsa out of it. And it's not directable in fine detail. So if you want some, like let's say in the middle of the motion to insert like a reach for the water bottle, something like this, is fine stuff. Is not easily doable. So this makes it suitable more for like easy sources of large volumes of organic motion. Might not be for your lead character, or you might use it as a start point, which is also cool. And then I wanted to talk to you guys about the components, like kind of how it works, the interesting part. So first we have the capture, and we have chosen Xsense just because it's the highest quality and portable system that from all the ones that we have tried. And the optical stuff doesn't produce as good of a result. It's also not very portable. And the the high quality inertia is portable. It doesn't take too much processing because we need to move very fast with our capture. We have a bunch of witness cameras, actually 2 witness cameras, not a bunch. So they give us visual context. So when we capture, I can even show you actually how it looks in the database. So that when we capture, we have both an idea about how the performer looked and an idea about how the motion looks. And this is live actually from our database, which keeps growing. So let's say one of the motions we just got in. So you can see the 2 witness cameras. This is a doll. It's actually not retargeted. It's just transforms which are being copied, which means that there is no alteration to the original motion. But this way, you also have access to the witness stuff. Let's see. In the meantime, has something happened here. I don't see that warm-up, so I'm just going to try again. So like you saw that we use the shotgun database, which is something that we have inherited from our VFX days to manage the capture and the animation data. And this makes it easy for us to do this kind of a versionized work. So when some motion doesn't look completely correct, then the supervisor can say, can we make this a little bit better? Can we change something, like somewhere there is some slide or something like this, which is very cool. And this is the kind of your bread and butter way of doing working VFX. And for this case, it's quite suitable. And this database also makes it easy for us to push a lot of stuff in there. So when we capture, there is obviously 2 witness cameras. There is a bunch of files like the scene from the MVN, the FBX, which take exports, processed, and yeah, witness cameras. So all of this stuff goes into a database, which is easy to then retrieve. So the raw captures are for us something which is like 3 to 5 minutes long. it's not very practical to capture a performer that is doing something which is too short, and you kind of recalibrate. So something which is a few minutes lets them get into the motion and have a productive day with not too much service time, like more performing time. So then what we do is that we splice these motions up and describe them. And this happens actually in Houdini. So there are tools that we have that loading up the motion, define a bunch of ranges where the different motions are happening, and lets you label them. And now we don't capture with gloves, just because our tests were not very conclusive that it's very useful. And instead we have a library of poses, of hand poses, that we use skeleton blend to blend to between. And we have a couple of sensors actually, not like for each finger, but just something that's kind of a paw kind of sensor, which lets you, do a open close. So we can do blend poses on top of that one, which is quite straightforward. But of course, there is a person who is looking at this thing, so there is a human in the loop. So somebody's gonna be able to see it. If you don't like a piece, then we can also edit it, fix it. So it's not something which is kind of gliding automatically. And yes, I ran into some problems. Live demos are risky. Then we have our backend. So this is the heart of the system. There is a bunch of smaller subsystems, and there is a traffic controller who is, sending stuff here and there. This thing is written in Python. Eventually, we're looking at writing it in Go just for performance when the load becomes a little bit too much. There is a RabbitMQ queue, which is feeding jobs to the Houdini server that I'm going to talk about in a second. And we are not using one of the traditional ones that we are used to from VFX, just because this is something that happens more on the developer side, and they are more used to this kind of a tool. We have a general purpose database, Postgres database that stores everything pretty much, which is on the stuff that the system needs. So this is besides the shotgun database, a bunch of database really that are needed. And the Houdini server is kind of the heart of the whole thing. So for us to get this thing to work as a web service, we had to make Houdini run as a web server. And this means that we can have a bunch of tasks in different Houdini scenes. We can make the server so that when it receives web requests, it can run the scene with some Python that executes particular, let's say, top nodes in the Houdini scene, but basically asks this Houdini scene to perform these particular things. And this is straightforward to write in fast API and expose the REST API endpoints, and then UVcorn is the server which is hosting the fast API interface. So this is all the tasks I think that our Houdini server is working on. So first we have the ingest task, and this is basically the upload of your character into the service. And this happens through a SOAP file node, which has issues because this way we don't get the shaders, for example, that we get if you do a scene import. And eventually, I guess we're going to be switching this around. But for now, this is a very, very easy way to do it. Then we auto-rig it. There is several open source research that we found. I think there was a DNEG repository in GitHub. So we just looked there and did some of our own upgrades to this. So now we can auto-rig with fingers and everything, which is quite nice. we have a sequencer. So that's basically a motion sequence, I think motion clip sequence SOP from the KineFX toolset, that when you have two animations, you can give it to a motion sequence and then give it some blend in the middle. And this whole thing goes through the full body IK, which makes it reasonable kind of kinematically, and you get a decent result. And we do retargeting, which is the same thing that you guys have seen on a bunch of demos, KineFX retargeting. And the cool thing there is that you need two things to retarget. You need the poses to match. So we just say to the user, please, upload your stuff in a pose. But there is a mapping between the joints of the new skeleton and the old skeleton. And we found out that we can ask the language model to do this mapping. So usually the joints are named with something that has the information, but it's just like different formatted. One thing is called left underscore, arm, and the other one is called arm capital L. So this is enough for the language model to figure out what are the connections. So then we have a topnet that does the sequencing work and exporting the things to files. Which one was my window? Yes, something crashed with our server. I'm gonna ask the guys to restart it. Okay, but you can see on the website, yeah, this is support, you go to the chat, you can see on the website stuff that, kind of some examples that are showing cool things that you can do, and the way that you can converse and comment on the motions and them getting changed and evolving. So here, this is cool that you say do a kick, and it does a kick, but then you say add a punch after the kick, and you get the sequence of punch and a kick. Abstract, interesting motions. We have a dancer that we like to capture with, and she's quite good on this modern ballet scene. So she moves in very interesting ways. And yeah, we have everyday stuff. We have yogas, whatever. The idea is that we are user driven. So if you need some particular thing to happen that we don't have it in the database, you just let us know, and in a couple of days we are gonna record it, and you're gonna have it there. We have about 600 new motions getting added into the database every week, like 100 something a day. Okay, so then the vector database, which is maybe one of the funniest parts. So the way that these things work is that, just like you have the usual 3D space, let's say the Cartesian coordinates, it's something which encodes a place, a point in space by giving a number for its width, height, and depth, let's say. But imagine the same, but instead of width, height, and depth, imagine fast or fearful or casual. So all of these are semantic coordinates, and let's say, and for each of them you can assign a value. So with a couple of thousand of these, you can have a position in space which is semantically describing something and not geographically describing it. And this is called embedding, and the language model is doing it. We're using the OpenAI language model right now, but we don't put too much stress on it. We can swap it with Llama or anything whenever we feel like. So what we do is that we label the motions, and then now we run language model embed into the vector database, which is encoding all of these descriptions as points in that space. And then when we give access to the AI agent to this database, it can basically find something which is semantically close to what you are asking for. And then it can pull it and send it to Houdini for sequencing. And when we say the agent, that's not the same thing as the language model, because the language model is a part of the agent, but there is a bunch of other parts. So there is the history, for example. There is the search in this vector database. There is access to the definition of the animation sequence that the agent can then change, and so on. So all of these tools together, built with LangChain, which is a very handy framework that you can do this kind of stuff in Python, is giving us the agent. And our front end that you just saw is quite simple. So we chose the let me see if I reload it, if it's gonna restart. So we chose the console format just because it's easy to build like this. It's easy to update. There is not, too much kind of a superficial stuff to do. And eventually, when we feel confident that it's more or less complete, we for the stage we can make it, fluffed up. And users are used to Midjourney and all these kind of models that they can just chat to, and this should be not uncomfortable. But our main kind of reason was also to be able to make it easy to integrate. So if you want to use it from inside Unreal or Blender or Houdini or Maya, you can actually have an easy time just writing something that calls the Python client and integrates and produce an integration. And our web app is just like a command line interface to this Python client. We also have an API access, obviously, because this is opening up extra sales opportunities to somebody who wants to embed it into a bigger platform. And I have a couple of examples here, actually, that are showing it as a Houdini plugin, because we have this built just for us to test. So if you look closely, the user said throw some punches, and then hits a button, waits for a few seconds, and then you get your character throwing punches. If you think that this kind of stuff would be useful to have in Houdini, then raise hand. And there is one more, I think, example like this. So here it says, I think, punch, then a kick, and then hit the button, wait for a few seconds, and you get some motions. I think here the sequence hasn't worked. Okay. And here after the restart, I asked for the warm up your knees, then sit down. So sit downs are kind of tricky usually because they involve some more complex stuff that is out of the topic here. But yeah, you can check her out that she has warmed up her knees a little bit and then does a motion that sits down. I can do another character. There is a bunch of pre-existing ones. So let's say this guy, and if I want to say cheer your team, I get first the agent response, because the whole thing is two steps. So first you ask the AI for, to pull up the motions, and then this gets sent to the Houdini sequencer to make animation, and they target to the character, and you get reports from both of these systems. So now the agent says, okay, this is what I found. I actually have a verbosity here, so if you care about some extra data, maybe a little bit too much here. Diagnostic purposes, don't worry. So now in a few seconds, the sequencer is also going to spit it out, and we are going to see the guy cheering stadium-like. Subscription-wise, because eventually, yes, we want to have this as a subscription platform. The idea is that you get subscribed, and all the time there is new stuff coming in, kind of a Netflixy effect that you don't want to unsubscribe because you're going to miss out on something. And it feels like a better business model than currently the piecemeal things that you're getting. So now you would go somewhere to download a motion pack, but it has some stuff, but not everything that you need. Then some other motion pack, then some other one. Well, in our paradigm, you just subscribe to the platform. If it doesn't have stuff, we're going to record it for you. You're going to get it as a part of the same subscription. Is much easier. So yes, that's pretty much it. I would love to get some questions from you guys. And if you go to this link or scan this code, there is a page that you get an invite actually. So you can create an account. There is a short video which is showing you how to use it. There is a link for a Discord, and you can even book a meeting with us. So our goal now is to put it into people's hands, see what they feel like, address their nodes so we can get it to a place where we can get some customers. That's kind of it. And here's the guy cheering. Sorry about the crashed server, but it was a fast fix. Okay, questions would be lovely.
Hello, great presentation, thank you. The sequencer data after calculating, is it available in Houdini so you can extend some of the movements or give more steps or stuff like that?
Yeah, so when you export, it's kind of the thing is in several steps, right? So every time that you say something to the sequencer, you get a result, which is a GOTF that you can read. But every time that you export, we make a package that contains the choreography, but also all the input motions. So basically, if there was 5 motions in this choreography, you get all of them. So if you want to do your own retarget, your own motion blending, you can just take the input motions and do that. And the choreography itself is something that has baked keyframes. So you can load it up anywhere, you can edit the keyframes, and do anything on top.
Awesome, thank you.
Eventually, we want to add hair and cloth because it makes sense now. When we're in Houdini, it makes sense to do all of these kind of things. Yes, files are going to get bigger, but we should figure out a way to distribute it. And you can then do stuff on top of it. We are talking to, for example, we asked the guys at Cascadeur, like, do you guys feel like this is interesting? That, you can use it as a start point for animation, basically. That you can, like, when you are a hairdresser, for example, you don't start from a bald head and grow up like new hair and then style it. You start with something that exists. So we hope that, this will be a quick starting point for people to get some natural motion in and then edit it maybe to fit it into some kind of directed, like other few details basically that it might miss.
Perfect, thank you.
Other questions? Yeah.
I just have a question regarding the, just one question regarding the return file. So you don't actually get it into your Houdini directly. You get a file from your service, and you then have to load it into Houdini?
This is like the Houdini client that we now had. Sorry, just a second. Where was that? Here. Our main case, I mean, what we have been doing, making so far is the web service that is going through the web app. Now the Houdini client that we had made, this is kind of our in-house thing, where it bypasses a bunch of the systems. So we would eventually make, like, if there is interest, we would eventually make a wrapper for the service which is run from inside Houdini, and it doesn't bypass the systems like this, but yes, we can give you BGO files or anything. BGO is our internal format. When we export, we create the FBX, etc., which is because if it's more multi-platform. But yes, you can get BGO files, but the package with several files just makes sense because there is different artifacts, different products from the process. Like this, there is several input files from this choreography. There is the choreography, so it makes sense that you get access to these. But if we want to make it kind of seamless from Houdini, then we can figure something out to give you like several packed geometries, for example, that have all of these different things, and you get like in your first output you get the choreography, and then you have other outputs that have packed primitives for each of the other like artifact products which are interesting. So this is up to whatever you guys say is good.
I have a slight follow-up question on that.
Yeah.
are you returning this as a rig or as a geometry character? So you're uploading your character. You can upload your character, as I understood, and you would apply the motion to that. But
Yeah. So yeah, we are giving it to you as an animation on a skeleton, and then the deformation happens. For example, with like if in Houdini you would pass it to a bone deform, or over here. The GLTF renderer is doing it in here in the viewport, and yeah, something basic. We try to avoid baking points just because it makes the files bigger. So it would be like more of a waiting to transfer files. But yeah, technically it's possible. For example, for when we do hair and cloth, we'll have to bake points, but it's a smaller file when it's just like in Houdini when you load up a character. You get on the first input the skin with its capture weights, and then you get other inputs for the skeleton, which contains the animation and has also a rest pose in an attribute. So it's pretty much the same thing.
okay, thank you.
Yeah, it'd be neat to see it sort of transferred to a different character in the demo, yeah?
So right now, if I, for example, now switch the character, it's not going to retarget automatically. We haven't done that. But that's just like adding one more operation to the Houdini server to be able to switch the character. And for us on the inside, this is not a huge deal because we have mapping for all of these characters who have been uploaded. Like once you do the Autorig, it creates the mapping. So it would just be like in our sequencer scene, it would be just switched to another file. But the work has been done already by the Autorigger.
Hey, you said you want to add a hair and cloth simulation. If I send a character to you, can you use it for that? Or because you have to detect what's the cloth, what's the hair, and what's the collision?
So the plan is to ask the users to have stuff in the names of the geometries. Maybe we could also extract all the names of the geometries and we give it to the language model and we can tell it like what here is cloth, and which if you have a bunch of different garment names in the cloth, it's going to figure all of this out and it's going to give us a list. So this would be cool. But yeah, this is the plan to get the names of the geometries from the names of the basically to get from the names of the geometries to figure out what is cloth, what is hair, and then do whatever it makes sense procedurally to build the rig. So for hair, for example, we know that we have to pin the points which are closest to the scalp, and for clothes also, you pin the post points which are within some distance from the character. Eventually, if this is not enough, you can deliver the Houdini scene that can be tweaked, or somebody can go there and touch it up. But yeah, this is the plan, to use the names to split them up.
Okay, and will it be done with a ML deform or something like that, or will
Sorry?
you do it? Will you do a traditional simulation approach then, or will you do like a ML deform or something like that, like machine learning approaches?
Yeah, we will do a Vellum.
Yeah. Okay. Thank you.
It's important that things are fast. Lots of users, hopefully. But you can do different tiers of complexity for, let's say, when you want to export, for example, you can run a simulation that has lots more points. And when you do preview, you can run a smaller number of points. The Houdini server is a container that we can just spin up like more containers, and the queue is taking care of sending like load balancing basically between the containers. So right now all the jobs are going to the same queue, and then the queue is load balancing. So eventually, let's say there is lots of slower jobs, you spin up more containers, you send tasks there, and yeah, Vellum stuff, and which is at some reasonable resolution, and then gets point deformed to the high-res render clothes.
Any other questions? Cool. Thanks, Hristo.
Thank you, guys. Cheers.